This video will discuss the use of the A&D RV-1000 vibrational rheometer. The rheometer itself has two main components, the measurement unit and the control unit. The measurement unit sits on top of an anti-vibration table to protect it from the influence of other instruments. Above this we have the sample stage. This can be adjusted in two directions horizontally here and vertically here. Moving upwards we have the sensor probes which are inserted into the fluid in order to make the measurement. And at the top we have a locking lever for raising and lowering the sensor head. There are three key parts to the sensor probes. These plates vibrate left and right at a predefined amplitude in order to apply a shear stress to the fluid. This is a temperature probe, which is important because many fluids will vary their viscosity with temperature. Finally, this level guide ensures that the sample is positioned correctly for accurate measurement. The rheometer takes samples of about 40 ml. In this example, we'll be performing a measurement on distilled water. First, the sample is placed on the stage and held in place by the guides. Next, we move the guard out of the way and release the locking lever. This allows us to squeeze the grips at the back of the sensor head and lower it into position. Next, we raise the stage until the level guide is in line with the top of the fluid. With the sample correctly positioned, we move to the control unit. We can cycle through the different amplitudes of vibration using the up and down buttons. These range from 0.07 mm to 1.2 mm. In this case, we'll use 0.4 mm, as this corresponds to the natural frequency of the instrument. We save the setting using the print button and begin measuring by pressing start. This begins the initial measurement phase, which takes 15 seconds to complete. Once this is finished, the viscosity is displayed on the screen, along with the temperature, and readings are then taken continuously. The device measures kinematic viscosity, and then converts this to dynamic viscosity by assuming a density of 1 gram per milliliter. When the measurement is complete, we lower the sample stage and release the locking lever, allowing us to return the sensor head to the upright position, where it's locked back in place. The sample can then be removed from the stage, and we remove any traces of the fluid from the measurement probes. Finally, we replace the guard. The rheometer can also be controlled using the associated software. In this section, we can choose the measurement interval and how long the experiment should run for. The program then begins plotting both the viscosity and the temperature as a function of time. The data is saved in CSV format, which can easily be imported into a spreadsheet for further analysis.